Good day, everyone, and once again we're back together. So we are looking at the photoelectric effect, right? If you haven't subscribed, please just do the right thing, okay? All right, let's get right into it. They say we've got an investigation that is done to determine the effect of the power of a light bulb on the current which is generated in a photoelectric cell. They say the apparatus used in this investigation is shown in the simplified diagram below. An ultraviolet light of wavelength 490 nanometers emitted by two light bulbs, A and B, right, shone onto the cathode of the photoelectric cell, and the maximum speed of the ejected electron is measured. Okay, so all right, let's essentially they are telling us all that we see there. They say the results of their investigations are shown on the table below, right? Right, so in this case they say describe the term photoelectric effect. Remember, we say this is the phenomenon where light is shone onto a surface. In fact, electrons are emitted from a metal surface through the use of light. Okay, right. So they say briefly explain why the power of the light bulbs rather, does not affect the maximum speed of the ejected photoelectrons. Okay, so to explain that quickly, we know that when we increase power, it only affects the number of electrons emitted per second, right? In this case, therefore, there will be more electrons emitted per second, but in this case, only increasing the frequency of light will actually increase the speed of the electrons, all right? So, or in fact, we can just simply explain that increasing the power does not affect the frequency of the light, okay? And therefore, the maximum speed will actually remain the same, right? Remember, only frequency in this case will increase the speed, okay? Right, so they say which one of the light bulbs, A or B, will produce the highest reading on the emitter, okay? Well, definitely it should be B, right? And they said explain your answer, right? So increasing the power of the light bulb will increase the number of photoelectrons emitted per second, all right? So as a result, the emitter reading will increase. Okay, so please remember that, ladies and gents. Rewind that if you need to. I will not write it down per se. It does take us a bit of a while if we do that. Okay, right. So they said to us in 10.4, calculate the energy of the ultraviolet photons. Okay, so remember we were given the wavelength. They said that is 490 nanometers, right? So to get the energy of the photons, all right, so 10.4.1, okay, we are not given the frequency, but we know that frequency is actually the speed over the wavelength, right? So this is hc over lambda, right? So h, that's Planck's constant, okay, so that's 6.63 times 10 negative 34. The speed of light, that's 3 times 10 to the power 8. And we know that our wavelength, we said this is 490 nanometers. This is times 10 to the power, nanometers, not times 10 to the power 14. Okay, right, so that's nano is minus 9. Okay, so please remember that. Okay, so let's take that answer. So that's 6.63 exponent negative 34. That's multiplied by 3 exponent 8. And we divide all of that by 490 exponent negative 9. Okay, Right, so we get that answer there, which is 40.59, or we can say 4.06. Okay, this is times 10 to the exponent minus 19 joules, right? So that's the answer we get over there. Right, that's 10.4.1, but what about 10.4.2? Okay, we wanted to find out what is the work function of the metal cathode, right? Now, I want you to note we were given at the top there the maximum speed of the electrons, right? So we can simply say to ourselves, right? We know that E is equal to omega 0, right, plus EK max. All right. So for EK max, we are given the speed of the electrons, so we can find out what the kinetic energy is, right? We already have E, that's 4.06 times 10 minus 19. We want omega 0, which is the work function, but here we are going to use half mv squared, but please remember, what is m? That's the mass of an electron, right? So to get omega 0, okay, we're going to say omega 0 plus half the mass of an electron. Please remember, you are given, that's 9.11, right, in your data sheet. That's minus 31, okay, multiplied by the speed given there is 7.5 times 10 to the power 5. So that's 7.5. And please remember, this is squared, right? And this is going to be equal to 4.06 times 10 minus 19. So all I'm going to do is take this entire thing to the other side. It becomes negative, and I'm going to subtract it from 4.06. Okay, so let's do this in the calculator. That's exponent minus 19. Okay, and I'm going to subtract that entire expression. That's 0.5 times 9.11 exponent negative 31 times 7.5 exponent minus, sorry, that's not minus, so that's exponent 5. Okay, and we square that. Okay, and right. Okay, for some reason that answer does not look correct. Okay, so I'll have to, all right, let's try that again. So I'll say that's 4.06. Okay, in fact, let's calculate that separately, right? So 0.5 multiplied by 9.11 exponent minus 31. Okay, and that's the mass multiplied by, okay, I'm gonna put this in brackets, 7.5 exponent 5, and this would be squared. Okay, right, and then I'm going to actually subtract. Okay, so let me do this. So I'll just have to change the sign, right? 4.06 exponent minus 19. All right, and that's our answer there. Okay, so our omega 0 would be 1.49. We can say 1.5, isn't it? So that's 1.5 times 10 minus 19 joules. I could tell that our previous answer somehow was just not the one. Okay, so That's 1.5 times 10 minus 19. And that is our final answer, ladies and gents. I hope that you got the same. Right, and that is how the cookie crumbles when it comes to this section. Otherwise, from me for now, ladies and gents, I'll see you guys again next time. And I wish you all of God's best when it comes to your physics exam. From me, I'll see you guys next time. Sharp, sharp.